We're going to be continuing learning how to solve linear equations. Now we're going to solve linear equations with variables on both sides. A lot of these steps are going to be the same, but we are going to add in a new one today. So what is our goal? Same as always, to isolate the variable. What are our steps? So first, we are still going to put that line through the equal sign, just so we can keep track of what's on what side. Then we want to go ahead and simplify our two sides. So the first thing you'll do there is to distribute. If possible, of course, if there's nothing to distribute, you can skip that step. And then we're going to combine any like terms on the same side. Again, our goal is to simplify both the left and the right sides by distributing and combining like terms. Once both of your sides are simplified, our new step is that we must move all variables to one side. Now this side is up to you. It's your choice. And then step 5, same as before, we are going to use our inverse operations to solve for the variable. And then of course, once you're done, you should check your solution, especially if it's a quiz or a test. All right, let's go ahead and try some examples. All right, question 1. Negative 2x plus 1 equals 4x plus 19. Let's go through our steps. So we're going to draw a line down the equal sign, distribute, well, nothing to distribute, and then combine any like terms on the same side. So on the left, I've got an x and a constant, a number. They're not like terms. These aren't like terms either, so I don't have any like terms on the same side. So we'll move on to moving all variables to the same side. So I have got a negative 2x here and a positive 4x here. You need to move one of those x's to the other side. Again, it's up to you. Some people like putting them on the left so that when you're done, it'll say x equals whatever your answer is. And some people like to do it to avoid negatives. So some people would rather move this 2 because they'll get to add instead of subtract. So let's try it that way. I'm going to add a 2x on both sides. So negative 2x plus 2x cancels out, and I now have 1 equals 6x plus 19. And now it should look more like the problems we've done so far, where there's only one variable and we're going to solve for it. So I'm going to subtract 19 next. 1 minus 19 is a negative 18. Divide by 6. And I get an x equals a negative 3. And you can, of course, rewrite that in the other order. Let's do a check. So for my check, same as always, I'm going to replace all the x's with my answer of negative 3. So I have negative 2 times negative 3 plus 1 equals 4 times a negative 3 plus 19. And again, you'll want to simplify the left side and the right side. And if we have the correct answer, both sides should equal each other. So on the left, I'll multiply first. Negative times a negative is a positive 6 plus 1. And then over here, 4 times negative 3 is a negative 12 plus 19. All right, back on the left, 6 plus 1 is 7. Negative 12 plus 19, which is the same as 19 minus 12, is also 7. So both sides equal each other. I know I have the correct answer. Number 2. X minus 10 equals 6x minus 35. All right, put a line down the equal sign. Distribute, skip that. Combine any like terms. No like terms here, no like terms here. Moving on, I want to get my x's together. Just to be different this time, let's try subtracting 6x on both sides. And remember, anytime there's no number, it's an invisible 1. So 6 minus 6x's cancels out. 1 minus 6 would be a negative 5x. And if you prefer to subtract 1x on both sides, that would work too. You'd still get the same answer. So now I'm solving for x, so I'm going to add 10. Negative 5x equals a negative 25. Divide both sides by a negative 5, and a negative divided by a negative is, of course, a 5. You can go ahead and verify that that answer is correct. 3 is negative 2 times w plus 3 equals 1 minus w. So this time I can distribute. We're distributing a negative 2. Negative 2 times w is a negative 2w, and negative 2 times 3 is negative 6, equals nothing to do on this side. Look for any like terms on the same side. No like terms here, no like terms here. Now I'm going to move my w's to the same side. I'm going to choose to move this one over to this side, so I'm going to add w, and if you want, you can put the 1 there to remember it's 1w. So negative 2 plus 1 is a negative 1. And those cancel, you're left with the 1. Go ahead and solve for w. Add 6. Negative 1w equals 7. And then to get rid of this negative 1, and even if there wasn't a 1 there, if you just wrote it as negative w, to get rid of a negative sign in the front, we just divide by negative 1. Because again, even if there's no 1, there's an invisible 1 there. And so a positive divided by negative becomes a negative 7. I'm going to show the check for this one because sometimes students get confused with all the negatives. So I would check this by writing negative 2 times a negative 7 plus 3 equals 1 minus a negative 7. So be careful here that you keep the minus in the original problem and write down the negative 7. So on the left, I'm going to do my order of operations, parentheses first. That's going to be negative 2 times a negative 4. And then this side, remember, if you have minus a negative, that all changes to plus. So 1 plus 7 is 8. And luckily, a negative 2 times a negative 4 is also 8. So both sides equal each other, and I have the correct answer. Number 4 is 4 times 1 minus x plus 3x equals a negative 2, x plus 1. All right, go ahead and distribute. I've got 2 things to distribute here. I get 4 minus 4x. That's not part of it, so I just bring down that plus 3x equals negative 2x minus 2. Now this time I do have like terms on the same side. On the left, I have a minus 4x and a plus 3x. So I can rewrite that as 4 minus 1x equals negative 2x minus 2. So I simplified that side, and now the left and the right are fully simplified, and I can move my x's together. I'm going to choose to move this x to the left by adding 2x on both sides. So for a negative 1 plus 2 is just 1x, so I can just write x equals negative 2. Then I'm going to subtract 4, and x equals a negative 6. And you can go ahead and check that one on your own too. Number 5 is negative 4 times 2x plus 1 equals a negative 8x minus 2. All right, I'm going to distribute. So now I have negative 8x minus 4 equals a negative 8x minus 2. All right, so there's no like terms on the same side. I'm going to move my x's together. So I'm going to move this one by adding an 8x on both sides. So these cancel out. Wait a second, negative 8x plus 8x, that also cancels out. That is 0. There's no x's now. So what am I left with? Negative 4 equals a negative 2. Well, that's not true. Negative 4 is never going to equal a negative 2. That's a false statement. So what that tells me is that this equation is never going to be true because negative 4 never equals negative 2. And so the answer to this problem is that there is no solution. So you must make sure if you get this false statement that you do write the words no solution, as that is the answer to the problem. And the reason this happens is because notice they both have negative 8x. So no matter what x is, this and this will have the same value. But on this side I'm subtracting 4 and on this side I'm subtracting 2. So there's no way that those two sides would ever be equal. Let's go ahead and do our last problem. Number 6. Negative 5 minus 9x equals 3 times 1 minus 3x minus 8. Simplify both sides. This side's going to stay the same for now. I will distribute the 3 to get 3 minus 9x minus an 8. And then I do have some like terms on the right side, so I will keep the left side the same. 3 minus 8 is a negative 5. Notice that both sides are now exactly the same. And so when I add my x's to move them together, like the last problem, they both end up canceling out. But this time I have negative 5 equals negative 5. And that is a true statement. Since it is a true statement, that tells me that the answer to this problem is all real numbers, or you could also write infinite solutions. Again, you have to write one of those two things as your final answer, and it's all real numbers because going back to this step, they're exactly the same. So no matter what number you put in for x, both sides will end up equaling each other. So every real number is a solution here.